Welcome to RGES Algebra 1. This is Lesson 29B. We will be discussing new concepts from 11.9 and 11.12, and 11.10 in your text. And you will need your textbook in order to follow along with that. So make sure that you have your textbook, if you don't already have it, as well as your homework from Lesson 11.8. Come back when you're ready to go, and we'll get started. Our scripture today is from Isaiah 26:3, and the Word of God says, "You keep him in perfect peace, whose mind is stayed on you, because he trusts in you." A few ideas here to notice. First off, you. Speaking of God, it is God himself who gives us his peace. A wonderful thing. Okay. It's not the peace of the world that is so dependent upon circumstances or my constant effort to try to maintain it in the midst of an underlying turmoil that I'm always pressing down. This, in fact, is a perfect peace. The scripture, Jesus says, he says, I give you my peace, not as the world gives it. Okay, it's not the world's peace. It's something much better than that. Okay, I give you my peace. So this perfect peace comes from the Lord, but it's given with a condition. Notice, whose mind is stayed. You keep him in perfect peace, whose mind is stayed on you. What does it mean to stay our mind on something? We continue, math requires a lot of staying of the mind, doesn't it? We have to focus, we have to press our mind onto something and think it through. It's not, usually for most students, it doesn't come easy. It's not natural, and the more you go on in math, the more you have to stay your mind. Sometimes you have problems that are 2 or 3 pages long to work out a single problem. If my mind were constantly distracted, there would be no way I could understand and keep on and solve that problem. I'd get confused if I was constantly being pulled away by distractible thoughts. Then I would get confused with what I'm doing. What am I trying to solve? What am I making out of all these numbers? What's my goal? Okay. Well, in the same way, we have to learn to stay. It requires discipline, a mental discipline, to keep our mind on the Lord. Well, what about the Lord am I keeping my mind on? I'm keeping my mind on who he is, what is his character, and what he has done. And if I remember and bring to my remembrance over and over during a day, whenever I sense myself getting anxious or getting concerned about something or beginning to worry, if I will stop and say, no, wait a minute, who is your God? Well, he's loving. He's powerful. He cares for us. He's good. He has my back. Remember that? He has my best in mind. Recall, remember. That's what staying your mind on him is. Bringing back to your remembrance who he is and what he has done. And then we do that. Not only do we remember, but what? We trust. Because you have done this in the past for me, Lord, because I have seen your loving kindness and your mercy in the past, I believe and am confident that you will give it to me again in this. Okay, that's trusting, right? So we base, and because your word of God has said that your mercies are new every morning, I trust that they are today, and that you will be merciful to me, even today, like you promise you will. Okay, that's trusting. Okay, so he promises he will give us his peace. It is a perfect peace. We gain it or lay hold of it or experience it as we put our minds on him and trust that he will do what he has done, that he will do what he has said. So that's my devotion here today, and I hope that encourages you. Now let's go ahead and give you your answers, and I'll be reviewing several problems as I go over the answers in 11.8. So we're looking at 11.8, and we're looking at 1 through 33 odd. Let me go ahead and read all the answers first so that if you have no problem with this, you don't have to listen through the lecture to get your answers. Number 1, 5, 3, number 3, 4, next, 5 and 1/12, next, 7.5, next, 6.23, next, 1 and 1/2, next, -3, next, 6. Oh, no, I'm sorry, null set, the null set. Number 17, -0.5, number 19, -2 and 18, number 21, 2.63 and -4.3, number 23, -2.38 and -12.62. Number 25, 23 over 10x, next, 5x plus 11 over x squared plus 5x plus 4. Next, 8x over x squared minus 9. Next, x plus 5. And finally, 9 over x minus 2. I'm going to do several of these as examples for you. We'll begin with number 1. Okay, first I like to identify the solutions that would not work. So x cannot equal 0 because we cannot divide by 0. If our least common denominator will be 0. If I multiply both the x, let's try that again. Our least common denominator is x. If I multiply everything by that term, the left side, the x's will cancel out. You'll get 4x minus 3. The right side, the x's will cancel out, and you'll get 17. So notice when the left side denominator and the right side denominator are the same and there's only one term on each, we basically just cancel out those denominators, okay? But this is the reason why we can. Okay, so never take a shortcut if you don't understand the reason. So I'm showing you all the steps. We're going to solve by saying 4x equals 20, and x, when we divide by 4, is 5. That's a legitimate answer, so we're free to go. Let me do the next, I'll do several of these here for you. For the next one, r cannot equal 0. Our common denominator will be 3r. In the left-hand term, the r will cancel out, and I'll multiply 3 times the numerator. In the right-hand side, the 3r will cancel out, and I'll be left with 7r plus 5. Solving. Now, always checking, making sure it's a valid answer, and it is. Now, number 5 will be the same thing, except that my least common denominator, I'll just go ahead and do 5 and then maybe skip a couple of the next ones. Here we go. My disqualifying answer would be x cannot equal 0 because the denominators would be 0 and you cannot divide by 0. My least common denominator will be 12x. On my first term, I'll cancel out the x and I'm left with 12 times the numerator. Minus, I'll cancel out the 3x and I'm left with 4 times 7 or 28. On the right-hand side, the third term, I'll be left, 12x divided by 4x is 3. 3 times 3 is 9. Going ahead and solving, first by the distribution. And when you're finished, make sure you check, and it's a valid answer. So I'll just leave it right like that. Now, number 7, there's no difference to what I've been doing. My Least common denominator that I will multiply by will be 35x. Number 9, there's no difference. My least common denominator will be 20x. And let's go ahead and look at number 11 together. Okay, my disqualifying answer, B, cannot equal -2 because -2 plus 2 would be 0. Okay, so my least common denominator would be 7 times the quantity B plus 2. In the left-hand term, my B plus 2's will cancel out. I'll be left with 7 times the numerator. My right-hand side, the 7, will cancel out, and I'll be left with this. Now, I'll go ahead and distribute and solve. B cannot equal -2, but when I solved it, it did not, so that's the answer. Now, notice one more thing about this problem. Let's go to the next page. A shortcut way to look at this is to realize that what I have here is a single fraction on the left and a single fraction on the right. So I could cross multiply and take 7b equals 3 times the quantity b plus 2, just like that. Anytime, this only works, one fraction equals one fraction. Only two terms, one on the left and one on the right. Now, if you get confused about when you can cross-multiply and when you cannot, then go ahead and work it the other way. Do not ever use a shortcut that you don't understand, because then you'll tend to use it for other things when you should not be using it. Now, number 13, if you look in your book right away, that's also cross-multiply. One fraction equals one fraction. So my first step, I could do 3 times the quantity x minus 7 equals 2x times the quantity 5. Let me go ahead and write just that part down. What I have here is one fraction equals one fraction. So my first step could be 3 times cross-multiply, top left times the bottom right. 3 times x minus 7 equals bottom left times the top right, 2x times 5. By the way, x could not equal 0 or 7. Make sure you understand that part, and when you solve it, x equals -3. So I won't do the solution there. I won't do the solution, well, in the next one, 15. Maybe I'll go ahead and show you that one. Okay, x cannot equal 3. I'm going to multiply. The least common denominator is x minus 3. It will cancel out in the first term. I'll be left with x. It will cancel out in the second term. I'll be left with 3. Okay, and in the right-hand term, right-hand side of the equal sign, I'll be left with 8 times x minus 3. Going ahead to solve that. Okay, so far so good, but when I go to compare, the only thing x cannot equal is 3, but my solution said that x was 3, so my answer is the null set. There is no solution. Okay, I'm looking for anything here. All these are going to have the same, well, let's see here. When I get down to 21, my least common denominator will be x plus 5 times x minus 3. I think I'll go ahead and do that one for you also. Okay, x cannot equal -5 or 3, because -5 plus 5 would equal a 0 in the denominator on the left-hand term, the first term. 3 minus 3 would equal a 0 in the second term, and of course the right side has no denominator, so we're not concerned there. Now, my least common denominator will be this. In the first term, the x plus 5 will cancel out, and I'll be left with 2 times x minus 3. Minus the second term, the x minus 3 cancels out, and I'll be left with 1 times, or just plain, x plus 5. Put it in parentheses. Why? Because otherwise your negative sign will tend to get lost where it really needs to be distributed, and the right-hand side will have to have both binomials to be multiplied, because there was no fraction to begin with that would provide me canceling. This will be a distribution, this will be a distribution. I'll need to FOIL and then multiply by 3. Let me go ahead and do that solving for you. Okay, so for this one here, a couple of tricky ideas. This got to be a longer problem here. Make sure on the right hand you understand that it has to be multiplied by both, so you have to FOIL that. Then you want to distribute your 3. Then, because we have the x squared term, we're going to write everything. We're going to, what we call, set it to 0. Everything's going to go, I'm bringing it actually to the right side rather than the left side as far as my x and my negative 11, so that I could end up begin with a positive in my first term. This you could think through, can I FOIL that? And that's got no good FOIL opportunity, so instead I have to choose the quadratic formula, plugging it all in using my calculator, as even when I got to that point, but especially when I'm taking the square root, and this will be my answers. Now, number 23 is the same type of problem. Let's look at 25 here. Now, I actually appreciate what he does in this book, because you notice this is not an equal sign. We've been solving. We're not solving now. We're just adding. So to add fractions, you need a common denominator. The common denominator will be 10x. This is fine, the 7, but this needs to be multiplied. If you divide 10x by 5x, you're going to get 2. 2 times 8 is 16, plus 7 more is 23 over 10x. I shouldn't put an equal sign there. Sometimes I confuse the students. Okay, we're not solving. Okay, that we're simplifying this. 23 over 10x, and that's my answer. Can't be simplified anymore. Let's go ahead and look at 27 on the next page. Okay, we identify our least common denominator. We will make that the least common denominator of both. So we'll just slip this up into the numerator over the common. Okay, one denominator, two numerators, or two terms in the numerator, right? What am I missing from the first one? I need the x plus 4 quantity. I need in the second one term, I need the x plus 1 quantity to get the common denominators. I'm going to distribute both. We'll get 2x plus 8 plus 3x plus 3 all over the common denominator. I'm going to gather like terms. This will be 6x plus 11. How about 5x plus 11? That's a better addition, isn't it? 5x plus 11. And I can leave the denominator just like this, or I can FOIL it out to x squared plus 4x plus 1x, or plus 5x, and 4 times 1 is 4. He tends to like this writing. I'm equally happy with this. It doesn't matter, but you might want to do this so that you can check it easier with what he's done. Now, the common denominator for number 29 will be x plus 3 times x minus 3. The common denominator for 31, it's already a common denominator. Right? So let me do 31, though, because it's got another tricky thing to it. Okay, notice we already have a common denominator, so we have nothing to change in my numerators. It will be x squared minus 25. But I always want to make it in simplest form, and I recognize that the numerator can be factored. And that allows me to cancel x minus 5 in the numerator and x minus 5 in the denominator, and my answer will be x plus 5. There's one more fun thing in 33. Some other trick you've learned. Notice these two denominators, x minus 2 and 2 minus x. would be the same, x minus 2, if I thought of this as having a negative 1 in front of it. Then this would be negative 2 plus x, or x minus 2 if I reordered it. Okay, so if this is the same as this if I take out a negative 1, or put a negative 1 in front. So this is the same as 5 over x minus 2, plus, because this negative 1 and this negative 1 make it a plus, 4 over x minus 2. Now we just say 5 plus 4, and that will be 9 over the common denominator, x minus 2. Okay, so there's your review. Go back and rework anything that was still unclear to you, and don't forget you can always text me when you if you do not understand. And now I want to go to the new concept, which will be in 11.9 and 11.10. And both of these are going to be problem-solving skills. So we're going to combine them, okay, and show you each of the sample problems and explain them carefully. So this is problem-solving, 11.9 and 11.10. I'm just going to walk through all the examples. So turn in your book to page 499. This first one's a fish problem. It says naturalists estimate that there are 3,000 fish in Lake Muchimuk. Some are perch and the rest are bass. They drag a fishing net through the lake and catch 24 perch and 21 bass. What is the ratio of perch to bass? So we want perch and we want bass. We have 24 perch and we have 21 bass. So there's a ratio, but you always want to express it in simplest form. So if we divided both of these by, let's see, 3, right? We're going to get 8/7. So there's my ratio. That's the first question. What's the ratio of perch to bass? The second question says, assuming that the entire lake has this ratio, how many of each kind of fish were there, including those caught? Well, how many fish are in the lake? And the answer is 3,000. Okay, now the second part of this problem says, assuming that the entire lake has this ratio, so this ratio will stay intact. We want to know the number of each kind. Well, if we have a 8 times a certain number plus 7 times the same number, that allows the number of fish to remain intact, or the ratio of fish. These would be the perch and these would be the bass. But altogether, whatever that number is, there's 3,000. Okay, so if we calculate that out, we'll say 15x equals 3,000. And then dividing by 15, we'll have x equals 200. Now, what does that mean as far as the numbers go? So that's just the multiplier. So for perch, it's going to be 8 times 200, or perch is 1,600. And for the bass, it's going to be 7 times 200, or 1,400. Altogether, that would equal 3,000. And the ratio, if we divided both these, we divide out the zeros, we divide 16 by 14, or divide both by 2, and the ratio would still be 8/7. So that works. Okay. Now there is another way to do this, and some of you students might enjoy this better. Let me show you, working just the ratio idea. There's my ratio of perch, and then because what I know about is the total fish, I would want to have the perch to the total. Well, the total would be 8 plus 7, or 15. And in real numbers, so that's my ratio proportion there. In real numbers, I have 3,000, and I want to know how many perch there are. So cross multiplying, I would get 24,000 times 15p, and I would divide, and I would get P equals 1600, so I'm cross-multiplying, right, like that. The P equals 1600, and how would I know the Bass? Well, altogether it has to be 3000, so 3000 minus 1600 would equal the number of Bass, which is 1400. So this is just another way to approach it. This is the way I typically approach it when I'm dealing with ratios. Either way, okay, two good ways to do it. Let's look at the next problem, which says the sides of a triangle have lengths in ratio 3 to 5 to 7. The perimeter is 90. We're going to do that the same way we did this first one here. Example 2, okay, says the ratio on a triangle is 3 to 5 to 7, and the entire perimeter is 90 centimeters. So the total then is 90. If I had 3 times a multiplier plus 5, perimeter is adding them up, right? Adding the 3 sides up, plus 5 times the multiplier, plus 7 times the multiplier. This shows me that they're in a ratio together, equals 90. That would be 15x equals 90, and x is 90. There we go. 36, that would be 6. Now, remember, this is not the answer to any one of the sides. That's not a side answer. That's a multiplier answer, just like it was above. So my 3 sides then would be 3 times 6, or 18 centimeters, 5 times 6, or 30 centimeters, and 7 times 6, or 7 times 6. Is 42 centimeters. So that would be my answer. Let's go to the next one on the next page. Freshman and sophomore problem. The freshmen at Scorpion Gulch High School outnumber the sophomores 7 to 5. It's really always important, I think, when you're doing a ratio, if it's 7 to 5, I like to label, these are freshmen, these are sophomores. So always remember what's going on here. If there are 231 freshmen, how many sophomores are there? Well, that would be like the way I illustrated doing example 1. I would set up a proportion. Okay, there's 231 freshmen, so the freshman is the top number, 231. We don't know how many sophomores. We would cross multiply. 5 times 231. We go ahead and do our arithmetic. Whenever I solve, I want to go back to what I set up and know where it fits in. So is this just a multiplier, or is this an answer? Well, in this second ratio, okay, this stands for the number of freshmen, just as it did over here. And this stands for the number of sophomores, both here and here. And so the question is, how many sophomores? X equals the number of sophomores. So that's our final answer. Now, you're going to do just the first 5 problems. So your homework, part 1, okay, here is going to be 11.9, 1 through 5 all. That's part 1 of your homework. Now let's go on to our 3 more examples. This first one is a rate problem. Rate problems are kind of unique, okay? Take a little bit of practice or a little bit of thinking. It says, a boat moves through the water at X kilometers per hour. That's the rate. It makes a journey 20 kilometers upstream. That would be the distance, against a current of 3 kilometers, and then returns with the current. Several things I want you to understand. First off, the basic idea. Always think about rate times time equals distance. Okay? So when we're thinking about the total time, let's solve this expression for time. If we're going to say t equals, we're going to take the r to the other side, and it's multiplying now, so it would be distance over rate. Okay. Now, we know that the time, the total time, is going to be the time upstream and the time downstream. That should be obvious to us. So I want to care about the time upstream, we could even do this, plus the time downstream. Now, we also know that there's a rate on the current, and the current is 3 kilometers per hour. Notice that's a rate. All right. And the distance, so this is a rate, okay, and the distance, so it's not the rate of the boat, okay, it's the rate of the current. The rate, let's try that again. Of the current. Okay, and so the rate of the boat is going to be x. Now, when we're going upstream, it's slower because we're working against a current. When we're going downstream, it's faster. So my rate upstream, so the distance is what? The distance is 20. That's right from the problem. Okay. We're going a distance of 20 kilometers in both directions. So my time is, and remember what it's asking in A, is the total time for the trip. That's why we solve for t. So the time is 20 divided by the rate. But the whole rate is going to be, we're going upstream, so it's going to be x, but we're going to be slowed down by our current. The rate downstream is going to be the distance over the rate, but the rate is the rate of the boat, and we're going to go faster because of the current. You see how that works? So this is A. This is the problem answer to A. The answer to B says, how long will the round trip take if the boat goes 10 kilometers per hour through the water? So you pause it and think about it for a second yourself without even looking at his book or anything, and see what you would do for that, all right? So in A, what we have is an expression already. Right? And then we're saying we have an expression for how long the trip takes. And now we'll say if it goes at a certain speed. So my expression for the time was 20 over x minus 3 plus, this is from A, plus 20 over x plus 3. This is downstream because it's faster. This is down. This is up, right, because it's slower. Right? And now what do? We're saying how long would it take if the r, this is the rate of the boat, is 10. So we're just going to plug in 10, substitute, and do the arithmetic. Now at this point, you could go ahead and make it a common denominator of 7 times 13 when we get to this point, and then add, but because we're going to want our answers in decimal point, go ahead and just get out your calculator, calculate that, the answer, and then add them together, and the answer is like 4.396, and then round it. Okay, now the third time it says, how fast must the boat travel through the water in order to complete the trip in 5 hours? Now remember, this is an expression of time. So we want the time to be 5 hours. What would I have to do for this one? I would have to take my expression and set it equal to the time. So in the second one, you're given the rate, so you're plugging in for x. And the third one, you're given the time, so remembering the expression is for time, I would just set it equal to, what did he say? 5. So finding your common denominator, you know how to do this. We've gone through a bunch of problems like this. My common denominator is going to be, okay, first off, x cannot equal 3 or negative 3. My common denominator is going to be x minus 3 times x plus 3. Then you will go ahead and use the quadratic formula, or the quadratic, the quadratic formula. A equals 5, B equals negative 40, C equals negative 45. Go ahead, plug it in, and you're going to get x, when you've simplified, equals x plus or minus the square root of 100 all over 2. Doing your arithmetic, you're going to get x equals 9. Now because, by the way, these come out as whole numbers and negative 1, you could have also done a factoring up here. Okay, so you could think that one through if you'd like. And then we're looking for what? We're looking for how fast the boat travels, so a negative number won't make any sense, and the boat travels 9 kilometers per hour. Okay. Now, one last thought. Notice the key to these. After you've gotten an expression with time, okay, so the whole expression is time, and the x is rate. Then, if he gives you a rate, you plug it in for the x. If he gives you a time, you set the whole expression equal to the time. Okay? So I'm going to have to go to a new tape. I'm hoping I'll be able to even upload this one. So let's go to part 2 on a new tape.